Now, one of the skills that we need to make sure and practice is finding the missing piece to the puzzle. So up in this example 3 above, we were given our x and y, and we needed to find r. And in a lot of these cases, we're given 2 of the things. We need x, y, and r, and we have to solve for a third one. So we just have some practice down here. You can see the answers are written out, but I do want to walk you through this practice. So I'm going to try some and then have you stop and try some as well, like we're used to doing. All right, so let me try number 1. I'm going to make a little bit more space here. So this number 1, we're going to solve for r. We're always going to be using this Pythagorean theorem, which I'm going to write in terms of x and y instead of a and b. R is always the hypotenuse. So I'm going to plug in x and y and solve for r. So this is going to give me 9 plus 16 is equal to r squared. 25 is equal to r squared. R is equal to 5. And that's my answer. All right, let me try another one of these. I'm going to come down and try number 4. So I'm going to try number 4. I'm going to leave some for you guys to try too. So number 4, same thing. X squared plus y squared is equal to r squared. I'm going to plug in 2 square roots of 3 squared plus 2 squared is equal to r squared. Be really careful about how you type this in your calculator. Some calculators are a little bit easier to use with parentheses, or they prompt you to use the parentheses, but you can type this in your calculator. What's going to happen is this is really 2 square roots of 3 times 2 square roots of 3. So 2 times 2 gives me 4, and the square root of 3 times the square root of 3 is really just 3, because that's the square root of 3 squared. They cancel out, and I'm just left with 3. And then plus 4 is equal to r squared. So that gives me 12 plus 4, which is equal to 16, is equal to r squared. I'm going to take the square root of both sides, and I get r is 4. So we got that one right too. Again, stop, rewatch as many times as you need to, because I know that one's a tricky one. Make sure you can type that in your calculator, that 2 square roots of 3 squared, to get that 4. If you're not getting it, really and truly try the parentheses. Make sure you've got these parentheses before the 2 and after you get done with the square root, and then type that square in. I'll be happy to look at this in person in class too. Let me do one more, and then let you guys practice finishing these up. So I'm going to look down at, I'll do number 6. So I've done 1, 4, and I'm going to do 6. So this time we're supposed to find y, given that we know x and r, and we're in quadrant 3. So just to remind everybody, quadrant 3 is down here. 1, 2, 3 are quadrants. And we're given -4 is my x value. So I would go over 4, and I'm given my r value. So I know x is 4, -4, and r is 5. So I've got to find y down here. Still using that Pythagorean theorem, but this time I'm going to plug in -4, make sure negatives get put in parentheses. I don't know why, and r is 5. So that's going to give me 16 plus y squared is equal to 25. I'm going to subtract 16 from both sides. I'm going to get y is equal to 9. Y squared is equal to 9. Take the square root, and y is equal to 3. The reason that it was important for us to draw the quadrant is because in quadrant 3, y is actually equal to -3. So you got to make sure and put the negative in there. That's because this quadrant right here, both the x and the y are negative, because we're going down 3. We can see right here we went down 3. So that's why y is -3. And in the next section, 2.3, we're actually going to talk about a little kind of mnemonic device to remember what's negative and what's positive in each quadrant. But for now, we've got this picture to help us, and that's why it's important to really draw those pictures out. All right, go ahead and hit pause and try 2, 3, and 5. And you've got the answers down below, but I'm also going to work them out so you can see those steps as well. But go ahead and give 2, 3, and 5 a shot. All right, let's see how you did with those. So number 2, all of these are using the Pythagorean theorem. I'm going to plug in -3 for x and -2 for y and solve for r. That is going to give me 9 plus 4 is equal to r squared. 13 is equal to, oh my goodness. Let me get back to that page in the notes. There we go. 13 is equal to r squared. Take the square root. R is equal to the square root of 13. So, yep, got that one right. All right, let's try number 3. It's going to be the same setup. We just have to be careful with our square roots here. Square root of 3 for x. Be careful of that negative. Square root of 2 for y, and I'm looking for r. Squares and square roots cancel out. My goodness. My iPad's just going haywire. Let me get that caught back up. So we were on number 3 here. We said the square root of 3 squared plus negative square root of 2 squared is equal to r squared. Squares and square roots cancel out, so that leaves me with 3 plus squares and square roots cancel out. It's hard to see that negative, but it's going to cancel too. Plus 2 is equal to r squared. 5 is equal to r squared. So r is equal to the square root of 5. Yep. I'm really sorry about my iPad here, messing up. All right, last one. Let's give number 6 a try. If you missed those, just go back, just rewind so you can see those. I know I wasn't able to leave that up on the screen very long. Number 5 is the last one we have to try. Hopefully it cooperates here. We're solving for x. Still use the Pythagorean theorem, but I'm going to keep x as my variable. Plug in 2 for y and 5 for r. And I'm also going to draw a picture for this one. We're in quadrant 1. We don't know how far over, but we know we're going up 2 and then a radius of 5. So we know y is 2 and r is 5. And in quadrant 1, both the x and the y are positive. So my answer is going to be positive, so that's nice. So back up here to the top, x squared plus 4 is equal to 25. Subtract 4. X squared is equal to 21. Take the square root of both sides, and x is equal to the square root of 21. The difference between this one and number 6 is number 5 is in quadrant 1, where both the x and the y value are positive, so I don't have to worry about making anything negative. So it is positive square root of 21.